Hello friends, welcome to my channel. Today is the day 2 for our PCNSA series. So in this video, we are basically going to discuss about the firewall fundamentals. So before we move on to the firewall fundamental, there are few things or there are basic things which we need to understand. And I'm going to address those points as well in this video. So in this video, I'm going to cover OSI model, TCP IP model, what exactly it is, why it is important to know, which devices works in which layer, how it will be beneficial for firewall, okay, why we need to know about OSI model, TCP IP model, and which device works in which layer, why we need to know about that. And the important thing is the stateless and the stateful firewall. What is the difference? So this is the basic thing, guys, to understand about the firewall. This is the starting, but this is just a beginning, guys. So I'll request you to please watch this video till the end so that you can understand this information, because it will be beneficial for understanding or getting started with the firewall. Okay. And also I'll request you to please subscribe my channel and hit the bell icon so that you never miss any video from me. So without any further delay, let's get started. And also guys, if you want to support this channel, you can just click on the join member button. Like if you want to support this channel, you can just go and click on the network support join button and you can join. This will basically support me to create more content of this and basically in a very better way. Okay, you don't need to join this firewall army because I'm not offering right now anything. So in upcoming months, I'm planning to do live streaming for firewall army, not right now. So once it is full-fledged, I'll be asking you, or I'll be sending you the schedule how we can do the firewall army live streaming with you guys. Okay. So friends, let's understand what is OSI model and what is TCP IP model. OSI model is a reference model which was introduced by ISO. Okay. Now before OSI model, what used to be is like, if a device wants to transmit a data to another device, they have to be same vendor. Okay, so if they are same vendor, then only they will be able to exchange the data from one device to another device. Okay, now think about the today's situation. Now we have n number of vendors. Like if I talk about Cisco, we have HP, we have Dell, we have Palo Alto, we have so many companies. If I want to communicate from one vendor to another vendor, it was not possible. So ISO thought about this model, and this model was introduced. This was a reference model, and this is the implemented model, which basically we are using it. But it is kind of a same that you can see in the TCP IP model. It's been merged, like layer 7, layer 6 and layer 5 has been merged, and it is called as application layer. Okay, and the layer 2 and layer 1, it's been merged. Okay, it is called as network access layer or link layer basically. Okay, and transport layer is a transport layer and network layer is a internet layer. Okay, you can also say network layer, there's no problem, right? So the reason behind building OSI model is because the different vendors can communicate from one device to another device. So if this is Dell, if it is HP, they will be able to communicate to each other with the help of this model. Now once they introduce the OSI model, the software of this interface, network interface cards, was designed in that particular, keeping in the mind of TCP IP model, and they started building that. right? So that they'll follow the same standard by all the vendors and they will be able to communicate to each other. Okay, this was the reason they have created this OSI model, okay, and they have implemented TCP/IP model. So there is no difference. You just understand the naming convention over here. That's all. Okay. So if you remember this as well, there is no problem. Okay. So friends, now we'll understand why it is important to know the OSI model and the TCP/IP model and which devices works at which layer. Okay. Now with the help of this diagram, we'll try to understand. Now let's understand this is a PC. Okay. And this is another PC, basically host A and host B. Okay. Now when this host wants to send a data, he'll be putting some of the information in all the layers. So which application is using, whether it's using any encryption or not, what kind of session ID, TCP, UDP, IP address, MAC address, and it will go to electrical signal through the interface. Now once it reaches to, for an example, it reaches to a router. Now as we say, router works at layer 3. What does it mean? It means that it can receive the traffic, it can see what is the information in the layer 2, which is basically a MAC address, what is the source MAC, what is the destination MAC, and what is the source IP address, destination IP address. Basically it can explore the layer 2 header and layer 3 header. But beyond that, he cannot go. He has no idea what is happening at that particular layer. If somebody is browsing something, he doesn't know what is the information in the browser. So he has no access to the upper layer. He only have access to that particular layer. Now for an example, if I have a switch here, okay. So in this case, in the switch, what will happen? Now switch works at layer 2. Okay. So if it is layer 2, then he can have access the receiving like the electrical signals, and then he have access to the MAC address. He doesn't know what is the IP address, how it works. He don't have access to it basically. So switches works at layer 2. They can access this information and this information, that's all. He doesn't have any access on the network part, right? So you need to understand at which layer which devices works. Now for an example, let's understand about the firewall. Now firewall understands more about layer 4, layer 5, layer 6 and layer 7 as well, because he needs to secure the application. He needs to secure with the information of IP address, with the information of port numbers. So he should know about the transport layer, and if I talk about as a TCP/IP model, the application layer, he needs to know about that, right? So that he can block the application. Why we need to block the application? Because most of the users and most of the applications, basically most of the traffics are based on the applications nowadays, right? So our firewalls can understand all this information, but you have to enable those features. We'll see how can we enable those features. How can we do that? What are the steps to do it? In Palo Alto Firewall, we are going to understand step by step. For now, you understand that firewall needs to understand all this information. Otherwise, let's say for an example, if firewall only understand till layer 4. So let's remove this. So let's say it understands till layer 4. Now, if some attacks that is happening at the application layer, what firewall will do? He'll not do anything, right? So if somebody is sending at application layer some kind of malware or application layer through the browser, so in that case, he'll not be able to understand and the attack will happen. So there is no need of a firewall in the network. Firewall has to be intelligent to understand that information as well. right? So that is the reason it is important to know which device is capable of which layer and what information it can understand. Okay. So friends, now we'll understand how it will be beneficial for the firewall once we understand all this information. Now we'll understand with the help of this diagram. So let's understand, let's say we have a sender and we have a receiver. Now we are sending the traffic and we are crafting the information in all the layers like layer 7, layer 6, layer 5, layer 4, layer 2, layer 3, and we are sending the data at physical layer. Okay. Now when we want to create a rule, right? If firewall can understand all the layer information, so when we are creating the policy, we'll be creating the policy putting more filters. So how the rules will be, for an example, this is the source IP, this is the destination IP, this is the destination port number, okay, and this is the application he can use it on, whether it should be allowed or it should be denied. So the more the firewall understands this information, the more granular control we will be having it. So that is the reason we have a benefits understanding these information, guys. Okay, so we'll understand more about it. How can we explore those options? We will be seeing in upcoming session. Okay. So friends, now we'll understand what is the difference between a stateless firewall and a stateful firewall. There are so many things which I wanted to talk to you regarding firewall, but this is just a basic understanding of a firewall. Okay, so let's understand that and then we'll talk about more details about it, okay, in upcoming session. Okay, so for now we'll understand the stateless firewall first and then we'll go for stateful firewall. Okay, so in stateless firewall, with this diagram we'll try to understand. So for an example, if this PC wants to send a traffic on internet to a server through this stateless firewall. Now for understanding purpose, you just not think about whether NAT should be there or not. It's going from in a private private IP address to public IP address, whether we should do a NAT or not. So don't include those information. Just now simply just understand the traffic. You just understand this is a public IP address. Okay, so the traffic is going to the server and returning from the server. Now while the PC generates the traffic, I have taken few information. Okay, and this is my source IP address. I wanted to reach to this destination, HTTPS, and this is my source port. Okay, now I've created a rule on stateless firewall saying that if the source IP address is this, okay, and if the destination is 2001.1.10 and destination port is 443, I will be allowing the traffic. This is my rule. Now the traffic comes to the stateless firewall. It accepted. It is going to the server. Now server is returning the traffic. So while returning the traffic, now my source becomes this, my destination becomes this, my source port becomes this, and destination port becomes like this. So do you think the stateless firewall will allow this connection? Because this is my rule. As this stateless firewall has no information that the traffic has been sent from the internal to outside or LAN to WAN or inside to outside. So he has no information about it. So while returning from internet towards our organizational firewall, this is different, right? It is not looking like this. So my source is 192.168.10.1, right? So it is not matching with this. So in this case, my return traffic will be blocked. Or else we have to create another rule, something like this. My source will be 200.1.1.10, destination will be 192.168.10.1, source port will be 443 and destination port will be 1024. Now once we open this rule, right, we are opening a external IP address to go inside our organization, which is actually not acceptable. We are opening a hole in our firewall because this is just a one traffic. We have multiple traffics. For multiple traffics, we have to open multiple rules, and we will be having a lot of rule in both the sides. Then only the traffic can go from this to this, from LAN to WAN and from WAN to LAN. We need, for single session to complete, we need 2 rules, okay, in stateless. Now stateless, I can give an example of routers. Okay, I'll talk about the types of firewall, guys. This is just an overview of it. Okay, so friends, let's understand what will happen for the stateful firewall. So in stateful firewall, let's say, consider this is the traffic which is basically going to this firewall. Okay, and in the firewall we have created this rule. So what is the rule? If the source is 192.168.10.1, okay, and if the destination is 200.1.1.10, if the destination port is 443, action is allow. Now why I'm not taking the source port number? Because it is not required. Source port numbers are very random in nature, so I'm not specifying any source port over here. Now I have this rule, so he'll just check the rule and it will basically create a session. So what exactly the session will be like this? So I am receiving the traffic from 192.168.10.1, okay, my destination is 200.1.1.10, my destination port number is 443. So I am receiving the traffic, so I created this state information, as well as I'll be creating one more state which is basically opposite of it. So my source will be 200.1.1.10, okay, my destination will be 192.168.10.1 and my source port number is 443. And let's consider if my source port number is 1025, my destination port will be 1025. So this is the traffic which is accepted by the firewall, and this is the traffic which will be a return traffic from the server. So that if you try to see this information, it basically matches with this information, and this will be created for temporary basis. So it is temp rule. This is only created when the session is initiated, and it is only valid for the session. So once the data transfer finish, the session is closed and this table will be cleared, and all these things will be removed from the state table. Now, so friends, in this case what happens is the state table will allow the return traffic. So we just need only one rule to allow from LAN to WAN. We don't need any traffic which is returning from the server. So my return traffic is allowed for that particular session, and I am allowed from LAN to WAN. So now in this case, the server cannot initiate a new connection. If it creates a new connection, in that case we have to create another rule for return traffic. So let's say if I want to talk to server, he can reply, that will be accepted. But if server wants to speak to me, it is not possible. We have to create rule for that. Okay. And this state table, as I told you guys, the state table is only valid for that particular session. We'll talk about what is session. Okay. It is only valid for this session. It is not, or it is not valid for any new connections. Okay. So that is the reason it is called as stateful firewall. Now, who invented this stateful firewall? It was and it is invented by Checkpoint Technologies. Okay. And the team who invented this, right, Nir Suk, was the part of that particular team. He is the founder of Palo Alto Networks. Okay. So guys, this is what I wanted to cover in this video. If you like this video, please give it a like. If you have any suggestion for my video, please do it in comments, or you can send me an email. Or else, if you want to get in touch with me, you can send SMS or message, not SMS, message to Instagram or Facebook. Okay. And there are so many things that I wanted to do it for these series, guys. So I am creating one community to discuss our issues like live issues, and also I'm planning for the live streams, guys. So I'll be updating those information. So that is the reason I'm requesting you to please subscribe my channel and hit the bell icon so that you are not going to miss any of the update from my channel. Thank you so much for watching till then, and I'll see you in the next. Thank you.